So in this question, a long straight wire carries a current 100 amperes. A particle having a positive charge 100 coulombs and mass 10 grams kept at a distance of 10 meters from the axis of the wire is projected away from it with a speed 10 meters per second. The maximum separation between the particle and the wire is found to be how much? And is found to be y into 10 to the power 10 meters. We have to find out y. First of all, let us draw the figure. Assume this is the straight wire, okay, in this particular plane. And before that, let us define x, y and z axis. So this is x, this is y, and this out of the paper is z axis. Okay. Now the current passing through this long straight wire is 100 amperes. Okay. Now at a point which is at a distance of 10 meters, a particle is projected away from the wire. So it is projected in this direction with a velocity of, which is v naught given in the question, that is 10 meters per second. It is projected away from the wire at a distance of 10 meters from the wire. When this is projected, then what is the maximum distance between this particle and the wire? That is the question. Now, if according to this convention, according to this notation, the wire is in positive y direction. The current is flowing in positive y direction and the particle is moving in positive x direction. Now what is the force acting on a particle? F is equal to Q into V cross B. This is a force acting on a charge which is moving in the magnetic field. Now applying this formula here, V cross B. Now what is the direction of magnetic field at this point because of this wire? You can place the thumb in the direction of the current and fingers curl in this direction. So the magnetic field at this point P is inside the paper here. Okay, so V is in this direction and field is in this direction. V cross B, the force will be in this direction. So initially the velocity is in this direction and the force because of the charge and magnetic field is in this direction, because of which the charge starts moving in this direction, in this path. Okay, so at some particular point the path will be in such a way that the velocity exactly becomes parallel to the wire. That means x component of the velocity becomes 0. This is the point where the charge has reached the maximum distance. We have to find out this maximum distance. That is equal to how much? Okay, and this path is not exactly circular path. Why? Because the charge is not placed in a uniform magnetic field, because magnetic field at every point is different, because every point is at a different distance from this wire. So it is not a uniform magnetic field. So this path is also not a perfect circle. Okay, but one thing is for sure, at any point the velocity and the force both are perpendicular to each other, because F is equal to Q into V cross P. Now let us find out this force. First of all, at any point, at any general point, velocity can be written as Vx I cap plus Vy j cap. At any general point, velocity can be written in this direction, and at any point magnetic field can be written as this direction. What is that? What is magnetic field at any point? We know that magnetic field because of a long wire is equal to mu naught I by 2 pi x, where x is the distance from the wire and I is the current passing through the wire. So at any point, magnetic field can be written as mu naught I by 2 pi x, and the magnetic field is down the paper, inside, going inside the paper. So according to this sign convention, it is minus k. Okay, so what is the force? We can find out force is equal to q into v cross b. So q into v is this much, that is vxi plus vyj cross b. B can be written as mu naught I by 2 pi x into minus k. Now multiply this, we know that I cross k is minus j, but again why we have one more minus, so it becomes j. So we have q vx mu naught I divided by 2 pi x, and we have I cross k, that is equal to j, but again one more minus, so it is plus j cross k. J cross k is I with a negative sign, so it is minus I. So minus q vy mu naught I divided by 2 pi x into I cap. This is equal to force. Now force can be written as mass into acceleration. Acceleration can be written as ax I cap plus ay j cap. Now we can compare this left hand side and right hand side. So m into ax is equal to coefficient of I cap, that is this part. Similarly, m into ay is the coefficient of j cap, this part. So let us equate m into ay equal to this part. So we have m into ay, that is equal to q into vx mu naught I divided by 2 pi x. Now we can write ay is equal to dvy by dt, that is rate of change of velocity in y component velocity. Similarly, vx can be written as dx by dt. Substitute these two here, we'll get m into dvy by dt is equal to q vx, sorry, q mu naught I, bx can be written as dx by dt divided by 2 pi x. Now dt and dt gets cancelled, so you have dvy is equal to q mu naught I divided by 2 pi m into dx by x. Fine. Now we can integrate both sides. Now initially the velocity was perfectly in x direction, y direction velocity was 0. So we can write initially velocity in y direction, y component of velocity is 0. Okay, and when the particle reaches here, let the velocity be vy. Okay, similarly x, initially the x distance is 10, and finally when the particle reaches to this point, x is x max. So we have vy is equal to, what is vy? Vy is the velocity of the particle when it reaches to this point. Okay, so vy is equal to q mu naught I divided by 2 pi m into ln x. Integration of dx by x is natural logarithm of x. So solving this, you'll get q mu naught I divided by 2 pi m into ln x max minus ln 10, that is ln x max divided by 10, that is equal to Vy. Now what is x max? X max is equal to 10 into e power 2 pi m Vy divided by q mu naught I. Now in this expression we know mass given in the question, mu naught is a constant, I is also given in the question. Why? But we do not know what is Vy, that is velocity or the speed of the particle at this point in y direction. In x direction it is anyhow 0, that is why this is the maximum distance. In y we do not know. But one thing, let this point be A and let this point be B. So from journey from A to B, what are the forces acting? One is the gravitational force that is acting downwards, that is in negative z direction. And at every point in its path, gravitational force is perpendicular to the direction of motion. So work done by gravitational force is 0. What is one more force that is acting? The magnetic force, because this is a charge moving in presence of magnetic field. So there will be some force acting on this charge. Now what is the work done by that force? That also you can say equal to 0, because at every point the force is perpendicular to the velocity, because force is equal to q into v cross b. So work done by gravitational force is 0, work done by magnetic force is also 0. So work done by all the forces is equal to 0 from moving from A to B. That means change in kinetic energy is 0. So here kinetic energy at point A should be equal to kinetic energy at point B. That is only possible when speed at point A is equal to speed at point B. So speed at point A is equal to 10. So speed at point B also should be equal to 10. So here we have to substitute Vy is equal to 10 meters per second. Substitute that in this. So we'll get 10 into e to the power 2 pi into mass is how much? 10 grams. That is 10 into 10 to the power minus 3 into Vy is 10 divided by, what is Q? Q is 100 coulombs. So 100 into mu naught is 4 pi into 10 to the power minus 7 into I. I is also equal to 100 amperes. 100 amperes. Okay. Now solve this. So 2 pi into 2 and 10, 10, 100. So how much will you get? This will be 10 into e to the power minus 3 plus 7, that is equal to 10 to the power 4 divided by 10 to the power 2, that is 100. 100 by 2, 50. 10 to the power 10 into e to the power 50, that is x max. So x max is equal to 10 into e to the power 50. Now in the question, the maximum separation between the particle and the wire is found to be y into 10 to the power y into 10 meters. So here we got 10 into e to the power 50. So y should be equal to e to the power 50. This is the answer.